Welcome to this sixth video of lesson number 4, Ratio and Proportion of Mathematics Part 1 of Standard 9. In this video, we are going to study about comparison of ratios. First of all, we will see why do we compare the ratios, and then we will see how to compare. Okay, so let's take one example where I have written some information in the tabular form. See, there are two persons, Ajay and Beena. Their savings are given, say, $3,000 and $4,000 are the savings of Ajay and Beena respectively, where their incomes are $10,000 and $15,000. Okay, now let's see what is the ratio of their savings to income. If we take the ratio of savings to income of Ajay, 3,000 is to 10,000. If we cut that 3 zeros, we will get the ratio as 3 is to 10. This is the reduced form. Whereas ratio of savings to income of Beena, we get 4,000 is to 15,000. Remove this 3 zeros, we can get this, okay, 4 is to 50. Now we need to compare that whose ratio of savings to income is better. Whether 3 upon 10 is better or than 4 upon 15. We need to find this. Okay. Now when we write the ratio 3 is to 10 in the form of 3 upon 10, it has become like a fraction. So whatever we do to compare the fraction, we have to do the same thing. Means what do we do to compare the fraction? For comparison of fraction, if the denominators are same, say if the denominators are 8 and the first here the denominator is 3 and the other is 5. So if you want to compare 3 upon 8 and 5 upon 8, when the denominators are same, we compare the numerators. Now we can see the numerator. Here the 3 is smaller than 5. That's why the number 3 upon 8 is also smaller than 5 upon 8. Correct? So out of 8 parts, if we are taking 3 parts, and out of 8 parts, then we are taking 5 parts, certainly this is going to be smaller than this. So when the denominators are same, we compare as per the numerator. Okay. If we have the reverse process, say if we have now say 8 upon 3 and say 8 upon 5, then how do we compare this fraction? Okay, when the numerators are same, what we do? I will take one simple example so it will be easier for you. Suppose I take the example of half and 1/4. Okay, so 1 upon 2 and 1 upon 4. If you want to compare this when the numerators are same, now by normal, just common sense also, we know that half of any object is always greater than the 1/4, that is quarter of the object. So we know that, so half is bigger than this. So when the numerators are same, we compare the denominator. Now as 2 is smaller than 4, then the fraction with smaller denominator becomes bigger than fraction with the greater denominator. So when the numerators are same, we have to go in reverse comparison of the denominator. This 2 is smaller than 4 and this 1 upon 2 is going to be bigger than this. So using the same rule, when the numerators are same, we will check which denominator is smaller, whether 3 or 5. Of course 3 is smaller than 5. So if 3 is smaller than 5, then this relation is going to be that 8 upon 3 is going to be bigger than 8 upon 5. Okay. So when either denominator should be same, then we can compare easily, or either numerator should be same, then we can compare easily. But what if in this case where neither the denominator nor the numerator is same? So what we can do, generally we make the denominator same. How we can make the denominator same? For that we can take the LCM of these two numbers, or what is the LCM of these two numbers? So if this 10 and 15, what is the LCM of these two numbers? LCM of 10 and 15, you can see that if we divide it by common divisor 5, 5 2s are 10, 5 3s are 50. So HCF of these two numbers is 10 and 15 is 5, but their LCM is 5 into 2 into 3. So 5 2s are 10, 10 3s are. So LCM of this is going to be 5 into 2 into 3. That is 10 3s are 30. 30 is the common denominator. So how can we convert this 3 upon 10 into 30? So we can multiply this 3 upon 10 by 3. So we can get this 9 upon 30. Okay. And how can we get 4 upon 50? 4 upon 50. How we can convert it into common denominator 30. So 4 upon 15, when we multiply by 2, we can get 4 to the 8 and 15 to the 30. So what do we find? Now as 9 upon 30, we have to compare 3 upon 10 is 9 upon 30 and 8 upon 30. Now we can see 9 upon 30 is bigger than this, as what will happen? We will get 3 upon 10 is also bigger than 4 upon 15. So this is the one way of doing. But can we do something in a little bit shorter time in a smart way? Certainly yes. So what we can do, now here we have found the LCM. Now instead of just finding LCM, suppose we just multiply that this 3 upon 10, suppose we are multiplying here by 15, okay, here also multiply by 15, and this fraction 4 upon 15, let's multiply by 10, okay, here also we can get the denominator same. Okay, now actually what we are going to do, as whatever the denominator we might get, which is going to be equal, we will not bother about it, we will just concentrate on the numerator part. Okay, so what is 3 upon 50? 3 into 50. 15 3s are 45 upon whatever the denominator we have. And here it is 4 10s are 40 upon denominator whatever we have. As we have the common denominator, we compare these two numbers, numerators 45 and 40. Now as 45 is bigger than 40, certainly this number is going to be bigger than this. And what is this number means? It is 3 upon 10 is bigger than 4 upon 50. Okay, so the logic I have explained. Now I will give you the smart thing. What we are doing, we are just taking the product of this 3 and 5. So we are multiplying the numerator of the first with the denominator of the second. So we are multiplying the cross, and this we are multiplying. So it is 3 into 15 and 4 into 10. Okay, we are just comparing these two numbers, and then if 45 is bigger than 40, and first product is bigger than the second, and the first ratio is bigger than the third. Okay, so let's see in terms of say ABCD. Okay, in terms of ABCD can be, which is useful for any numbers. Generally, when we take the ratio, we take the ratio of the positive numbers. So what rule, as a rule, we can have? So for comparison of ratio, if A, B, C, D are positive numbers, then comparison of ratios, which are the ratios? A upon B and C upon D. So ratio of first two and the ratio of next two can be done as follows. How to this to be done? If AD is bigger than BC, AD means what? It's cross multiplication. So A into D, and another multiplication is B into C. So the first product AD, if it is bigger than BC, then the first ratio is bigger than the second ratio. Here actually when we are multiplying this, see when we are taking A upon B and C upon D, when we want to make this, compare these two ratios, we are trying to equalize the denominator. This A upon B, here we are multiplying this both numerator and denominator by D. And here C upon D, this we are multiplying by D. So the numerator is now AD and denominator is BD. And here the numerator is C into B, that is BC, and the denominator is D into B, that is BD. So when we have two denominators equal, we have to just compare the numerator part as the denominators are same. So when this first product AD is bigger than the second, then the first ratio is bigger. What if AD is smaller than BC? If first product AD is bigger, smaller than the second, and the first ratio is smaller. And if you have both the products same, then both the ratios are also same. So this is the thing which we have to do for comparison of ratios. Let's solve question number 2 from 4.2. Sorry, it's question number 3. For practice at 4.2, compare the following pairs of ratios, in which we have been given certain ratios which we have to compare. Okay. So the first pair is given to us square root of 5 upon 3, and the another ratio is 3 upon 7. So considering this as first ratio, this is A and B, this is C and D. What we have to do, we have to take product in this cross root. So what we will do, therefore square root of 5, this should be multiplied by square root of 7. So this is square root of 7 over here. So take this product of square root of 5 and square root of 7. which is equal to under square root 5 sevens are 35. Now take the product of this BC, that is 3 into 3. 3 threes is 9. Now we need to actually compare these two numbers. But we can see that one number is irrational and the other is rational. So we cannot at present compare how to compare square root of 35 and square root of, normal 9. But can we write both the numbers in the same way? Either we have to find square root or we should write 9 under the square root sign. Okay, so here we cannot find square root of 35 as 35 is not a perfect square. But certainly we can write 9 is the square root of which number. So what we have to do, when we are writing this number under square root, what is the opposite action of taking square root? Taking the square. So this should be written as 9 can be written as square root of 9 square. So taking square root and of a square of number, it will get again it is 9. Then what is 9 square? It is going to be 9 square is 81. Okay. So what is the product of A into D? Is square root of 35. What is the product of B into C? It is square root of 18. Now we can compare these two numbers. Instead of comparison between this, now we can compare these two numbers. We know that as 35 is smaller than 81, and square root of 35 is smaller than square root of 81. Okay. As this is the relation between the two natural numbers, the same we will find in square root. Okay. And as this first product is smaller, therefore the first ratio here, therefore your answer is going to be square root of 5 upon 3 is smaller than 3 upon square root of 7. So we can compare like this. Okay. Now we have to use the same method for the next sums also. Let's see the second sum where the pair is given 3 square root of 5 upon 5 square root of 7, and here it is square root of 63 upon square root of 125. Okay. Now we need to take the product of these two and these two in such a way that we can do its comparison. Okay. So let's take the product of therefore 3 square root of 5 multiplied by square root of 125. Okay. What do we get? Let's see here. We can write here below also. So 3 is rational. Under square root we have 5 into 125. Okay. So it is 3 square root of 5 into 125, or 125 can be written as 5 into 5 into 5. Anyway we can go for it. So it's 5 and this 125. If you do not know that 125 is a perfect square of 20, perfect cube of 5, you can multiply and you can check. 5 5s are 25. 2 here remains. 5 2s are 10 plus 2 12. 5 1s are 5 plus 1 6. So square root of 625. So 3 into what is the square root of 625? It is 25, and that's why we got this product as 75. Let's see what is the product of square root of 63 and 5 into square root of 7. So here we have taken the product of A into D, and now let's take B into C. Okay. So here this product. Now square root of 63 and into 7, let's take it, and 5 is out of the square root side. So here it is 9, 63's factors are 9, 7s are 63 into 7, and this into 5. Now square root of this product we can write over here. The square root of 9 is 3, and square root of 7 into 7 will get it 7. Okay. So 9 is a perfect square, its square root is 3, and pair of 7 into 7, 7 7s are 49, its square root is 7, and this should be multiplied by 5. Now just check this. 3 7s are 21 into 5. Take the product. 5 1s are 5, 5 2s are 10. Okay. So now we have to compare these two numbers, 75 and 105. Let me write here. Okay. So as we know that 75 is smaller than 105, that means AD is smaller than BC. That's why the first ratio, that is 3 square root of 5 upon 5 square root of 7, is smaller than square root of 63 upon square root of 125. Okay. So this way we have solved the second one. Now let's go for the next sum. The third one is comparatively easy one. So third one is the ratio is 5 upon 8 and the other is 17 upon 121. Okay. Now let's take the product of A into D, that is 5 into 121, which will give you 5 ones are 5, 5 twos are 10, 5 ones are 5 plus 1 6. Normal product, take the product of 8 into 17. Okay. Now what is 17 8s are, or you can say here 8 7s are 56. So 8 ones are 8 plus 1, it is 30. Okay. So I think here the number is 18, not 8, 18 into 17. So let's take the product of this 18 into 17. If you know table of either 18 or 17, you can go. Otherwise, if you don't know table, you can multiply this by ones by 7 and ones by 1. 7 8s are 56. 7 ones are 7 plus 5 is going to be 12. Now when you multiply by 1 in the tens place, you have to put 0. 1 8s are 8, 1 ones are 1. Now do this addition. 6, 10, 3, 306. So this product is 306. Okay. So actually the ratio is 8, 5 upon 18 and 17 upon 121. We have taken the product of AD, which is 605, product of BC, which is 306. Now as AD, that's 605, is bigger than 306, your answer is 5 upon 18 is bigger than 17 upon 121. This is our answer. Okay. So this is the comparison between these two ratios. Now fourth one is similarly here square root of 80 divided by square root of 48. Then the other ratio is square root of 45 upon square root of 27. Okay. Now take the product of first square root of 80 into the square root of 27. You can write here is 27. Okay. Comma square root of or if you want to simplify it here, you can simplify it. AD is like this. Let's take product here 0, 8 7s are 7 is a 56, 5, 8 to the 16 plus 5 is going to be 21. And what is BC over here? Square root of 45 into 48. Certainly you do not know tables of 45 and 48. So take 48 and multiply it by 45. So 5 8s are 40, 5 4s are 20, plus 4 is going to be 24. Put 0, 4 8s are 32, 3 here. 4 4s are 16, plus 3, 90. 0, 6, 2, 1. So it's square root of 2160. So what do you find? The product of AD and BC are same. Okay. So as AD and BC is same, that square root of 2160 is equal to square root of 2160, given the both the ratios are equal. That's why square root of 80 so whatever relation we find in the products of AD and BC, if AD is bigger, first ratio is bigger. If AD is smaller than other, first ratio is small. And if AD is equal to BC, then we get the two ratios are equal. Now let's see the last sum in this type, where we have the numbers in the decimal form. I have shown all these 4-5 sums just because whenever you find students find that square root and all that, they get confused how to do calculation part. There is confusion. That's why I have purposely shown all these sums. So now the fifth sum is say 9.2 upon this 5.1, and the other ratio is 3.4 upon 7.1. Now we have to follow the same procedure for getting the product of AD. We have to take the product of 9.2 multiplied by 7.1. So we will take this product and then we will take the product of 3.4 into 5.1. We will compare which product is better, which product is bigger. If first is bigger, then the first ratio is bigger. So for this, let's multiply these numbers 92 and 71 without the decimal point. I have not copied the decimal point over here. Now let's multiply, get the product of this 2, 1 to the 2 and 9 over here. Multiply by 7, put 0. 7 2s are 14, 7 9 is 63 plus 1, 64. So addition is 2, 13, 5 and then 6. So the product is here 6532. This is the product of 92 and 71. But as we have after decimal here 1 plus 1, 2 digits. Here also after 2 digits we should have decimal point. Okay. For 34, for this product we have to multiply this numbers 34 and 51. 34 into 51 when you multiply. So we get by multiplication by 1, we get the same. Multiply by 5, 5 4s are 20, 5 is a 15, 16, 17. So here we get 1, 7, 3, 4. This is the product of these two numbers, but as here decimal, after decimal we have 1 plus 1, 2 digits, here also this. So we can compare now. 65.32 is bigger, and 65.32 is bigger than 17.34. This AD product is bigger than the BC. That's why the first ratio is bigger than the second. So therefore 9.2 upon 5.1 is the bigger ratio than 3.4 upon 7.1. Okay. So whether you get the numbers maybe decimal or maybe irrational, do not get scared. So we can do this in this way. The only thing in ratio, we want the numbers to be positive. Okay. So this was the comparison of ratios. We have solved question number 3 from practice set 4.2. I hope you have understood the sums. If you understood, please give me likes, share it with your friends, and if you are not a subscriber to the channel, please subscribe, and do not forget to press the bell icon. Thank you very much. Keep watching.